I am pleased to introduce today's speaker, Dmytro. If you have any questions during the lecture, please ask them in the Q&A panel, and Dimitri will answer all of your questions afterward. So welcome, and I think now the floor is yours.
Laura, thank you so much for introduction. Appreciate this opportunity to present our expertise and share with you our experience working in a domain for autonomous mobility. Thank you for participating here, and let me start our lecture for today. I'll share my screen and go through the slides I've prepared for you. And should you please stop sharing?
Sure, I will stop right now.
Oh, cool. And here we go. These are the slides for today. Hope you may see my screen by now, and I may proceed further. Great. So again, I'm Dmitry. I'm engineering director in GlobalLogic. I'm responsible for scaling expertise in computer vision, machine learning, and nowadays with generative AI across the Europe. You may find some profiles and references on a page, including some GitHub small snapshots for both computer vision and generative AI, and you may find more helpful information on my link. So for today, topic of the future autonomous mobility. We'll go through several points. Specifically, we cover what is the landscape, what are the market players, and what are the market trends we may oversee currently in this.
Sorry, Dimitri, to interrupt. I just found out that our chat was not started, so I had to do some changes in the options, and now everyone should have the right to speak. Yeah, look, we have Natalia says hello. So sorry for that. Yeah, now it's working. Okay, good. So now we can also speak with our participants. Hello, all. Nice to see you here in the chat. Yeah, now everything should be fine. Thank you. Sorry.
No problem, no problem. Thank you for your active participation and appreciate your comments in a chat room. All right. So also today we cover what are the internal sensor and external sensing, as well as go over some success stories of early adoption of generative AI, as this is a very novel technique for a quite conservative automotive market, even though there are a little early adopters which are using this technology even for automotive. So let's get started. The landscape of the autonomous mobility. The reason it's now mobility, because as traditional market was for original equipment manufacturer like BMW, Mercedes, it's not the case anymore, as more and more mobile operators are getting into this market too. Like AWS, they are doing software-defined vehicles. You may see Google startups like Waymo, those doing autonomous mobility. So mobility is the new word of the autonomous driving. What are the landscape of the autonomous mobility? Typically, it's sliced into different domains, like the original classification of the like manufacturers. They are Mercedes, BMW, Toyota, etc. Now we have autonomous mobility, which are software-defined vehicles and solutions from cloud providers. We also have other building blocks, like autonomous vehicle stacks. These are technology to enable the autonomous mobility, like computer vision, pedestrian detection, lane keep assistance, etc. Also, there are a little more stacks, like doing a mapping, navigation. There are some connectivity and data processing. But the most interesting is software and algorithms, as well as data handling and tools. The reason for this, we as GlobalLogic are contributing into these domains. And these are example of the market players. You may see a lot of well-known names are there for different stacks, including like processing connectivity, software, and algorithms. We may explore later this picture to understand the initial flavors. Now, how the autonomous mobility is transitioning into different levels of autonomous driving. Well, nowadays we are on the driving assistance, and the term like advanced driver assistant, like ADAS, is a very well-known term for original equipment manufacturers. But ahead of us for the partially automated and highly automated, even full automated, is still a big roadmap to transform the experience of driving. Like partially automated means, well, we can partially do some maybe parking assistance or maybe adaptive cruise control. So these features are quite well known, and I believe you are using them intensively for assisting you into driving highway or parking your vehicle. The high automation, which is level 4, is all about doing this even more automated way when driver is just all about to make a control of the driving. Well, it's something like autopilot in the in a fleet in the airplanes, or this is a kind of autopilot for doing train transportation, but it's not yet in the autonomous mobility. Even though Tesla is quite well approached into the highly automated level. A full automated means you don't control vehicles as you need to do this. Nowadays, vehicles are automatically transitioning you from point A to B. And this is a projection of how many different levels of automation would be shipped to our market. So these are the slices, like how many cars would be produced. We are now somewhere here that I think like 30% of our market is still very classic, and maybe up to 10% are a good automation level, which Tesla can provide us. But the true level 5 is not yet as we may expect. Well, it's maybe there with the driving taxi in California, which sometimes are off license and they cannot operate. But in other domains, like maybe transportation in airports or in some restricted area, this level 5 can be a case. But not yet on the road of common usage. So this might have come in the next 5 years or so. Market trends, how these trends are transitioned into a different level of the driving experience we have. Well, based on the PricewaterhouseCoopers classification, there are 5 major trends we experience currently, and they are here. The electrification means more and more vehicles are now electric, and another trends like making them autonomous, basically what we just said the last 5 minutes, to automate the transition from point A to B and make it more robust and more safe. Few more trends are making your vehicle shared. So you don't own your vehicle, you just hire it, you lend it. And this is a new way of your experience, as you maybe don't need to possess the vehicle all the time. Instead, if you just live in a big city, you may need a taxi just time to time, or use a public transportation, or you're doing like bike or any other smart transportation in smart city. So shared is another trend. Our vehicles might be shared as like property, like Airbnb is shared. Perhaps shared experience of providing vehicles for other fleets or delivery or taxi might turn our experience to. Anyway, experience in providing you car lease is another trend upward. More connectivity is all about make your car fully connected with 3G, 5G, and 5G connect. It means your experience in navigating your smartphone can be projected to what you're doing in your vehicle. So You entertain, you learn, you shop yourself in when you go and drive from city to city. Means connectivity is a way to transition your experience by connecting your smartphones and gadgets as part of your ecosystem in a way. Finally, year updates and new mobility services is another trend. Some services may be turned off and on, like this story about BMW kids of the back seats, and they may just turn it off as your subscription ends. So technically, you may use your hitting feature, but when your subscription ends, you cannot use it anymore. So yearly updates and using different software updates is another way to give you a better safety and better experience as your vehicles turn to be a software-defined one. Now, let's talk about some computer vision and sensor fusion as core components of the autonomous driving and ADAS. ADAS is the Advanced Driver Assistance System. This is a typical sensor setup you may find on your vehicle. Typically, they're equipped with multi-camera setup, radar, and sometimes LiDAR. It means that it may give you a sensor fusion technique to control over surrounding events and objects. Like here, this is a LiDAR, which stands for laser measurement of the distance. And you may just understand the density of points, clouds, and the way they may see the picture around the car. There are different producers of the LiDAR, like IRS from Continental or Levox as the separate provider. They may differentiate in the depth of the points clouds or resolution, as well as the angle, like vertical and horizontal. It's still quite expensive technique, and Tesla doesn't use this, as it's give another 5 or even more thousand quid on top of your price. So not everyone in a mass production is ready to run this cost on top of your normal vehicle experience by giving you extra LiDAR with your machine. Instead, the technique is to leverage more from cheaper devices, like maybe radars or maybe a multi-camera setup to guarantee pretty much same accuracy, but perhaps to not address all the corner cases like driving in the dark or addressing some other corner cases for the like shadows when some computer vision cannot give you a high quality picture or the image is not great quality at all. Instead, LiDAR also have a flip side effect on the rainy weather, on the foggy conditions. So the best is to using sensor fusion like LiDAR and camera, but again, it's give you additional cost because of the LiDAR high price. Let's compare LiDAR versus radar. The density of point clouds in LiDAR are much higher. So these are the points of the surrounding objects on the driving scene. So you may even like try to catch that these are the buildings or these are other vehicles upcoming, like Advantage or Fright. Instead, for the radar, it's not high quality of the data. You may even recognize type of the vehicle approaching to you, and even some other objects, they cannot be accurately recognized. So hopefully radar will give you much same density and lower price soon, as this is another trend to start using radar to switch off the LiDAR because of the cameras. Again, examples of the range radar and example of points we may detect using the radar heat map as a reflection from the surroundings. Now, interior and exterior sensing. This is all about to fuse the data from sensors like camera and LiDAR and give you some helpful functions like lane keep assistance or parking assistant, and many more. This is an example of the gaze tracking as feature, which give you better control over your distraction level. So, for example, in Toyota, you may experience some voice or some like a big signal. Hey, driver, would you like to have a coffee cup? As it seems you're tired. And part of this technique can be done just very easily, just evaluating the time you're running without stop. But there are much more interesting techniques like track your gaze, track your way you keep attention on the roads. So if you just have a blurry view or you're not focusing accurately on the object, but you're just looking straight, hey, that's a warning. Your gaze may be not full of attention of the road events. And this is an example how to do this gaze tracking with simple computer vision technique. Train neural network with classic and deep learning methods both to control over gaze. And this is an example of predicted trajectory of your gaze versus the actual one. Same for pose estimation. It means, hey, if your pose is kind of distracted, so you don't control over the road, but instead you're just staring on your mobile phone, or you're drinking coffee, or you're just talking with your kid sitting on the back seat, it's another warning which may give you a pose estimation feature. All of them are quite common now in the most of the cars, like gaze detection and pose estimation. So they are quite helpful feature to make our driving more safe. Another example for control over your gaze and tie this with the position you just look into a road is to like associate your internal or in-cabin sensors with the road camera. It means that in many fleet companies, and basically we provide this kind of services for fleet companies to control over driver safety and driving accuracy for drivers, especially on heavy tracks or on a kind of fleet of taxi, whatever. So we have a device which monitors the in-cabin situation. Basically, it controls your gaze and your pose of the human body effects. At the same time, there's a road cam, which just monitor over situation on the road. But thanks to the gaze evaluation and pose estimation, you may more or less accurately evaluate whether the driver can watch over the situation ahead, but not just look somewhere in a typing SMS or being distracted. That's an example of how to estimate pose, estimate the way driver is driving safe. And then back to the camera setup, like in cabin and camera view, we may evaluate the pose of the head, and we evaluate our gaze with respect to the road origin. And this is an example of the transformation we may do with this technical solution, like calibrate camera with the internal view to some like calibration cube, do pretty much same with another cube for surrounding camera, and then we understand how these two cameras are tightened. So how to transition one camera to another, and this transformation and rotation is basically a matrix which we may derive from the calibration. With that, then we may recalculate gaze from in-cabin to the gaze to the exterior system. And that's an example how the camera position may understand the gaze and the pose with respect to the road or cabin. This is just an example of typical solutions and offering we give for our customers in a fleet management. Little more about the safety features, which may give us interior and exterior sensing. This is all about to control whether you're not distracted, you're compliant with your just driving policy, especially on a fleet. Means that you need to control whether your like pose, your gaze are compliant, and train your deep learning system to handle different type of scenarios. So your system should accurately detect males and females, different race and ethnicity, different type of closures, different type of the lighting condition, etc. With that, it's too difficult to shoot all the footage and all the variety of potential drivers, as you need to shoot the actor, as actor is driving car with different dress, different face accessories. But using generative AI or some generation methods can do a synthetic data, which you may use further for train your detection models over mixture, synthetic and real one. So that's an example how to make synthetic data for further software models in deep learning to detect position and identify items. Yeah, in the meantime, I see a few raising hands. Probably we may just go back to the questions at the end of the session, unless it's something like really emerging. So please be patient and let's have some discussion at the end. In the meantime, thank you for collecting all your questions and contributing into chat room to come back to this discussion later. Thank you. Another example of the exterior sensing, but now for evaluating position of the vehicles with respect to some origin, like a road camera to detect position of vehicle, potentially speed, direction, etc. It may help you to build another control over the trajectory, safe driving, and help with some autonomous mobility to send some signals back to the vehicles which potentially may have a collision. This is another project we did recently for our partner in North America to build like autonomous system to avoid the collisions with help of smart camera, which monitor of the trajectories of vehicles and prevent collision if trajectories may collapse. Some success stories over early adoption of generative AI. As this is another technique quite emergent, and we in GlobalLogic heavily use this not only for doing chatbots, but for much more other helpful functions. But first off, just to review how the market leaders are tackling the generative AI nowadays. So there are a few successful cases, at least. Toyota has claimed they use a generative AI for design, so they may be more efficient or more quick and more robust in producing some sketches or 3D models, or improving the airflow over the shape of the car by reducing the resistance and improving other parameters. So this is all about generating different type of the content, including 3D models. Continental, which we are also working together on a number of projects, and GlobalLogic was awarded by Continental as the gold outsourcing provider last year. We have confirmed this status because of the providing high quality solutions for Continental, and it gives the power of generative AI and Google Clouds for most of the vehicles equipped with their hardware. So in a few years, the GPT model will be operating in every vehicle Continental equips with the hardware. It means that teaming with the Google Cloud gives you a very great level of assistance. You may ask for your ChatGPT, like, hey, can you give me a better way to navigate to my destination point? Or, well, hey, can you help me to arrange a little trip around the most interesting sightseeing point? And at the end of my destination, please get me a pizza delivered in time. Sort of this assistance from GPT models and connected vehicles is the next experience to integrate cloud, software-defined vehicles, and large language models. This is a typical example of how this may work in a nutshell. So on the left-hand side on your fleet, you have the orchestration API you may work with. So fleet can communicate, and every vehicle may just send some message to another vehicle, like vehicle, or even vehicle to everything. So vehicle may ask assistance from navigation, shopping, security, etc. Underneath, when the orchestration API works with some sensor data, like data sourced from telemetry, from logs, any other alarms from the fleet, and from the CAN signal, these data are helpful for AI assistants to support you with better security, navigation, and at the same time, external connectivity to enterprise level of the ChatGPT or similar model can give you a secured way to talk with your GPT model, as guarantee your data cannot leak outside and not use it anymore for training elsewhere, but stays in a private cloud and private. These are typical cases as our customers and like end users leverage from generative AI. From the customer level, as the customer producer, they leverage from virtual assistants as Mercedes-Benz and generative model gives this, as well as some autonomous vehicle and ADAS for Tesla and other producers. On the other level, the business process optimization with generative AI is possible too, like making a better sales materials, better marketing materials, transforming the way sellers just approach you to give you a better choice, like give you better subscription plans, better like tuned vehicles for your personal driving experience, shared connectivity, all are there as part of the solution offering, which can be fine-tuned to generate. Other than marketing and sales, generative AI can be helpful with the software development tool. So if you use some Copilot-like products, basically I use this every day to help and just be more productive in software development. I cannot imagine a software development with Copilot anymore, as it's really saving my time a lot. But much same we may do with not necessarily code base like Copilot does, but with documents, with requirements, with data and other digital artifacts. So this is another opportunity for generative AI to leverage from all your data and infrastructure to build chatbots and some advisory system on top of the data, digital artifacts. We have 20 minutes left before the session. Maybe it's worthwhile to go over Q&A, but then back to another topic if you'd like to focus a little more on specific domain. So here I would just like to pause and give a word for you to discuss some questions, as this would be an open discussion. Thank you. Should we start? What stands behind the word generative in terms of generative AI? Thank you, Alexandra, for asking. The term generative means AI essentially don't understand the content. It cannot give you a true judgment or true decisioning or recommendation. No, it's just repeat some patterns exposed early. For example, when you talk about like generating a synthetic data for deep learning algorithm, it means we just go over database of some faces we saw before. So we just generate this face and embed this into a picture. Much same with text. It means out of multiple texts and multiple like corpuses, it just gives you a most probable continuation of your prompt. It means it just generate the next wording. It just generate how the sentence can be complete if you give the first part of the sentence. That's the term generated. So it's all about making a next prediction of the signal based of your series of it. How big the fleet it can process? Yaroslav, thank you for asking this. I'm just trying to give my explanation here. So in terms of the fleet, fleet is something like hundreds, sometimes thousands of vehicles. So imagine fleet as the taxi company which operates in your city. It means it may serve for not necessarily vehicles, but maintenance, your drivers, your supporting team mechanics, your fuel station, your parking station, and etc. It means the fleet itself is not only about your vehicles, but this is about making fleet management more profitable and more sustainable. So the offering for the fleet management can sound like this. Hey, like ChatGPT or advisory system, is my fleet like balanced well enough to run the business with respect to my operational cost and with my revenue? Like, for example, if you equip all your fleet with Mercedes-Benz S-Class and operate in Chicago, it will be like luxury, but would it be profitable? Who knows? My same questions can be answered about, hey, assistant, do you feel the distribution of my fleet across the city is optimal? So we are good in response time, resolution time, and quality of delivery. This is another example how fleet management can leverage from generative AI by reducing the operational costs, at the same time generating new revenue streams, like understanding market segments and approaching proper market segments with solution. Again, Yaroslav, thank you for asking about fleet size and the way generative AI can help. Alexa Moilinka, I'm C++ developer and interested in a computer vision, especially for automotive. My C++ experience be a plus, and what other skills you advise to gain the transition successfully? Thank you so much for your willingness to switch into automotive domain, and appreciate your question here. So C++ is really must-have for embedded software development, and it's really must-have when you work with developing your model for target platform like NVIDIA or other competitors on the market like Renaissance or Intel. So C++ is really good to deploy this model, to adopt this model into a target device. At the same time, it's just my recommendation based on my experience. It's good to have some hands-on Python just because it gives you a better shape to prototyping algorithms and test them locally before you start doing a C++ version. It means your like line of code in Python can be 50 lines of code in C++. The task you need to validate in Python might take like 5 times longer if you use C++. Again, it much depends on the skill set, but generally quick prototyping is much better with Python. It wouldn't go to production as it's still not performance optimal with with contrast to C++, but that's a good way to have a little Python for quick prototyping. But there is one more thing which essentially transforms the experience in a software development for automotive. Again, I'll just go back to this slide. Maybe it's not as accurate as this could be with the virtual and 3D modeling, but nowadays, this approach for simulating the data, especially like simulating conditions for exterior sensing, is like transforming the future of autonomous driving. Means you may simulate any type of scenario with low cost and with safe, and security approach by like simulating crashes or simulating some dangerous driving, whatever. So nowadays, no one trying to shoot the footage for different type of collisions. Instead, software like Unreal Engine or similar is the new way for artificial data simulation. So that's another recommendation for you. And think of the some Unreal Engine or similar products to simulate it. Great. Edward, what could be the next stage after generative AI? Well, generative AI opens a Pandora box. It means from the end user perspective, it's good. You as the user should not think a lot and should not like have a lot of the main experience how to problem solve. For example, last time I stopped thinking how to write a proper Python payloads or proper Python styling. Copilot does it for me. Is this good or bad? Well, okay. From the code level accuracy and code styling, maybe it's good. Is it good for me? So I stopped remembering some like cap style conditions, or I just forgot to write a low level Python. Well, arguable. Perhaps GenAI just optimized my time to write the software. But if you don't use it responsibly, you may ask some questions to Python assistant, but stop understanding the domain area at all. So sometimes your software development turns to be not a technical writing, but prompt writing. So you stop writing your line of code with Python dialect. Instead, just communicate with the chat assistant. Hey, assistant, write me a button. Hey, write me the API. Hey, write me payload. Involve the API. Is it good or bad? Well, it might be dangerous. I have no answer for this. At least I think we as the software developers should understand the mechanics of the atomic components and should be able to run the end-to-end development even without Copilot. So what will be the next stage after generative AI? I think the answer is a proper regulatory, a proper control of responsible use. Thank you for asking this. It's important. Ivan, all the features you described seems to have a huge impact on the way the driver controls the vehicle. It means that the notion of safe driving will change dramatically. What do you think about a danger of the vehicle being not under the full control of the driver? What would be the risk of the unauthorized remote control over a moving vehicle? That's pretty much reflects with the previous question. Until we have 1 million mileage testing, which proves that safety driving with the generative AI or different technique is really safe, we should not like license it for use. It means like in statistics, you may predict the value, but you give the safety range. Same in a autonomous driving. You may predict the trajectory, but we have a safety range plus minus 5 meters. Again, the safety like indicators how many crashes with respect to million miles have current drivers? Like maybe 1 crash per million or 2 crashes. How many of the crashes would have the autonomous mobility vehicles per million? Do we have enough mileage? Do we have enough conditions to validate this? I'm not sure if we have an answer for this question, even until we start gradually test this on a limited roads, on limited segments, limited cities. And again, as the typical software development, from prototype to MVP to global availability, this should be tested in isolation first, in limited conditions, but then scaled further. Thank you for this question. It's really important to address security. Pavlo, will today the practical part I'll describe in a course description? Thank you. Yeah, Pavlo, I will just I share very quickly how this may work but then let me just answer a little questions before I go into a practical. Hope we have time for this. So in order to make some multi-purpose solution, we'll need a bunch of the neural networks connected with some orchestration tool. Yes, Andrei, yes. We call this agent. Agent means we have a tool, much same as your tool in a Linux or any tool which may run application based on your payload. So you say, okay, this is the data frame. Find me a certain condition with the SQL. So SQL tool is a great example of tool. Financial modeling is another example of tool. This may just ask you, hey, give me your revenue stream, and we'll give you profitability. Again, tools are something you may give data. You may ask a certain operation to be executed there. Now, as orchestration API comes into a scene, it means we instruct our generative AI about tools, what they are doing, what are the atomic operations, and how generative AI should prepare payload into a tool and understand the payload out. With that, as you have the natural query upcoming for your orchestration, this one understands, okay, what number of tool and how, in which order I need to run it to hit the, to achieve the goal of the initial. So we call it engine. Engine is something operates with tools and execute the initial request from user by orchestrating tools in a proper chain. I can just check whether I answered this question. Yeah, so this is the way of the neural networks should understand how the tools are established, and then the goal of the neural network is the proper orchestration. That's the normal way agent works. Yaroslav Kazakov, fantastic, great model. But thank you for appreciating this, Yaroslav. Alexandra, could you please explain in more details the internal how the generative AI operates? VectorDB with good estimation, is this the only thing used? And how wide is the system? How many databases, servers, in how many locations? Okay, well, right, VectorDB is the essential part, right? It means when you run your query to your agent, you give your natural language context. With this context, you need to find some proper documents or proper images, whatever, something which resonates with your question. And VectorDB is the reason to make this resonation found accurately. It means, Euclidean distance is a distance between vectors. There are other distances like cosine distance or kind of like a dot product or correlation, whatever. But the thing is, every text or every query may be transformed into embedding. Embedding is just a representation. A very simple example, you may just have your vector as the binaries of the letters inside the query. It's not accurate, but it's just an example for you. Parent embeddings are representations as the outcome from neural networks. So every image or every voice or every text can be represented as the vector. That's the reason VectorDB can compare them and find the most similar vector before you do another call to your LLM, large language model. We call this RAG, retrieval augmented generation. So we have some retrievals first, which resonates with your initial query retrieved from VectorDB, and then we ask a question for large language model. Hey, this is a query, this is context for you, can you give me an answer? What about the volumes? How many databases, servers? Well, sometimes it's just enough to have one laptop, like on my laptop with the video card. I may operate with real-time questions and answers. That's the power required so far. It doesn't need any powerful device or powerful cloud. Even though on the CPU, you may run a more simple models like Llama and achieve more or less good level of use. Hope I have answered this question, Alexander, but feel free to clarify with Steve. And another question, thank you for your active participation today. Is it LiDAR technology determining the size of the vehicles on the vehicle you showed? If not, which technology is used? The dimensions of the vehicles on the slides we presented today are pure computer vision. Hope I just referred to the right picture you are, Alexander, asking. So this one is just computer vision. We may evaluate the field of view. We may evaluate the camera extrinsic parameters, like setup with respect to the origin. And then we may evaluate the physical distances. As when we know the field of view and we more or less understand the typical dimensions of vehicles, like in average, like Skoda Octavia is 4 meters and 80 centimeters long and 1 meter 80 centimeters width. Like this, we use this parameter to average the vehicle dimensions to evaluate camera position, but then we may bound box objects and evaluate their physical dimensions here. So it's not LiDAR. This is camera technology, but coming back to the LiDAR is possible too. But here in the example of the LiDAR, you may source from data sets from Newson. Newson is a well-known data set of the radar and LiDAR. So in the Newson, you have the LiDAR point clouds. Potentially, you may localize point clouds here, detect that this is a track, and evaluate dimension. Yes, that's possible. That's another way for evaluating physical dimensions. Valerie, could you please tell me how you measured real gaze direction? Real gaze direction. You may find this on my GitHub. In a nutshell, you may see this repository with instruction. I tracked it. So we have just a train set of the images. Basically, we have a number of images where we train our system. What was the gaze? So for every image, we just give This is the camera footage, and then we have example of the annotation, like markup. What was the position we put our gaze on? And with that, we just train our system to detect a point of the interest and train the computer vision system to evaluate these things. Hope this may answer your question, but then just feel free to navigate to my GitHub and explore more details. Okay. Which language used for software for ECU that responsible for autonomous driving in car? Typically, this is a C++. Sean Alexei, how soon can the AI buy a clutch disc for my car? It's simply a case for aftermarket, but doesn't solve it for me. I have no exact answer. I need to test this. Perhaps I didn't test yet whether the entertainment and shopping is quite mature, but the AI assistants with the other helpful routines like navigation or like personal parameters fine-tuning, they work good. Probably shopping experience needs some like pre-authorization and supervision, but overall I expect this might be quite thank you, Alexei, for asking this. Valery, question, which language used? That's the address. Okay. Alexander Mikhailovich. But all the sensors and computers are indeed power consuming in terms of the amount of them, not for one entity or some product, but for a population level. Would this outer sensor on board help it with that, or just adding power consumption? Is there a way of make system with lower consumption? That's good chat, Alexander. That's really good chat. The thing is, system like generative AI, they require power. They really power consuming. Is this good or not? Well, it's industry. And that's just the cycle of industry. Sometimes we are just forced to use some product on the market. But is it really good? Sometimes you just need to pay more for better design. You may need more for some features you may not use at all. Is UI a type of like added value with not proven benefits? It's difficult to say. Much same on power consumption as you asked. Right, so at the one hand, power consumption of the small semiconductors, they are smaller every year. On the other hand, more heavy devices are coming into the market, like LiDAR and like the GPT models for AI assistance. So my take that power consumption is only increased, unfortunately, which is not very heavy and good for the our like ecosystem on the planet. So potentially we need to have a proper evaluation whether electrification reduce the power use in general. I hope yes. At the same time, a proper utilization of electronic vehicles should be regulated. Valentina, the next question, how much will the most of the modern car with AI system depend on AI part? Can you still drive such as if something wrong happened with AI software in cars? Yes, there are thousands of cases when Tesla can drive in a wrong way. How is this addressed? Well, first of all, Tesla never said this is the level 5 autopilot. No, you as the driver is the one who is responsible for the crash. That's something you may find in your user manual, in your agreement. So you are the goalkeeper to use this technology. It means it can assist, it can assist, but you should not claim it as you're the one who's responsible for safe driving. So again, if you're just using the back radar to park your system, your parking radar, you cannot claim your car manufacturer that you bumped another car just because you use the wrong components. So much same with generative AI. Unfortunately, many of users stopped thinking and validating what AI gave them. Sometimes we believe for generative AI's answer as much, so we don't treat them as something we may counter check or check with another system. So again, it's difficult for me to answer Valentina for your question by now that how we may claim of AI give us a wrong recommendation. I think the essence is we as human beings should never stop learning and should continue be a subject domain expert, but treat AI as assistant only. Alexander, another question for you. Computer vision will require very good quality of video, right? Yeah, right. For certain type of task, yes. But again, coming back to the examples we explored today, for example, gaze tracking. Okay, gaze tracking was with the just normal camera, 720 pixel. Exterior sensing and evaluating car position. Again, this is a road camera with HD, so it's not even 4K, which means that not always, and that's good, not always we need a high resolution to run some AI analysis. In the answer, the generative AI predicts the next word, but how it understands the prompt question? That's a good question. LLM never understands us. No, that's marketing. The model is simply running in a cycle, some kind of regression, some kind of function, which simply predicts what would be the best fit to continue your time series. For example, you as a human being can predict what I can say next. 2, 4, 6, 8, 10. Your prediction will be 12. Much same on the large language model. It means with help of the self-attention mechanism in last technology for transformers, they may calculate what would be the next best continuation to your time series. And your prompt is just a start of this series to be answered. There underneath, as you give some prompt, like, hey, give me the question. It understands that, it's not understand, it just trigger a proper function. Hey, this is the intent. This is not the continuation of your question, no. It's user intent to go into your other corpus of text and continue some sentence. With that reasoning, with that understanding, intent recognition might be somehow understood as the understanding. But again, LLM doesn't have understanding. It's just extrapolate the network. And Valery, thank you very much. Here there are predict and fact. Predict, it was a trained model, right? And fact is also trained. Not much. So fact is always fact. Fact, it means ground true. Something we as humans labeled the model as the fact. And predict is something model has predicted. And then we just give a feedback loop. And then we just train our backpropagation method to reduce the delta in fact and predict. Mariana Keller, currently, do we have any requirements for the Automotive AI to be sure it's ready for commercial use? What testing is performed? Well, globally, GenAI is already commercialized. We pay our subscription fee for ChatGPT models, for Stable Diffusion, for Copilot, and many more. So they are commercialized. Are they tested? Partially, yes. The recent leakage from the OpenAI security team situation, the security team just quit and say the proper security measure wasn't taken over the last release, whereas the functionality and profitability were prioritized. This says that testing and security testing might be not addressed as much as commercial product can. For example, if you ask your GPT model, hey, can you write me a spam message? Most likely it would not do it. It just says, sorry, it's not allowed to help you with spam messaging. But I personally try to trick this to just get some test data for our spam filter training model. And surprisingly, when I prompt LLM with different words, saying, hey, wouldn't you write me an email message approaching people to buy some product? It just didn't spot out I'm acting as a spammer. So sometimes you may cheat model and force it to make bad things. I really believe that a type of like crime or adverse attack or many other bad things I even would like to mention here are quite well tested to LLM not help in assisting with this. But we never know. We never know as this type of vulnerability testing and security tests are never reported by those companies. And I understand why, because if we have this report, we potentially may understand how to cheat and how to turn this to work as that. Okay, we have just a little time. I'm not sure if you still have enough attention to do little practice, but just try this. So I think you might be interested in doing a very simple training of your models and get into a world of the object detection, segmentation, and classification. I highly recommend you to test and play around with Ultralytics package as the new version of the YOLO model. They deliver the YOLO version 9, which may give you a good accuracy for detecting models in a real time. So you have the model repository from Ultralytics, and they have an excellent quality of the examples. You may train your model, you may just validate your model and run them in a real time to detect models like this. So, for example, when you have your open, like development studio or your notebooks, this is just 5 lines of code you might try with training for models. You just simply import YOLO from Analytics. You just default the model name with the predefined name, like 8 version Nano, which is the fastest one. And you say, hey, train me on the certain data set. You may put an open data set like common object in context, but you may give also a data set as you create them yourself. So for example, if you just go into a training pipeline, you have your LLM model right here. You have images, you have annotated data like here. You have the picture data sets. You have the image folder, for example. You have images. And you have the associated labels to each image. For example, here we say frame number 1, and we have label with certain coordinates. We have some object types. We have cyclists. We have pedestrians. We have the car, like vantage car. And this is an example of annotating data on your image. Of course, it's not well suited yet for being trained on YOLO. So you may go back to the like labeling format you should provide for training this pipeline. But at the end, just give a data set like this. You say, okay, for training my data, I have, for example, the images like here. For example, you have some cube and pyramid as images. You have like ground truth data. So you say for each frame, you have certain object ID, you have certain coordinate, and then you give this as the data for further training the model. Eventually, you just give more and more footage to train these type of objects. And then you simply run a script to train this, like this, like detect, train. And you say, okay, hey model, do a train to detect and take my data sets from here as the fully packaged folder with classes and images for you to start training process. And just start training. Here, somewhere under runs and detects, it will go with some like labels and some examples how those labels will look like. This YOLO pipeline will give you an example of the trained and validated images and the accuracy as the backgrounds effect. So again, the training process is straightforward and simply train it like this, classify, provide the folder images, and here we go. If you really love to go into a deep of the training, just please again navigate to my GitHub account with example how to train this and do some practice. But today, I believe, in the nutshell, this would be a good intro for you to understand the command line interface and examples, how to train your model for doing detection, classification, and segmentation. Okay. Dora, maybe it's good time to just give control over to you. Perhaps you have some comments and other questions for today's session.
Yeah, sure. I have a few of slides for finishing. I just want to make sure that everyone. Oh, sorry. I have to start also my camera so you can see me. So I would like to ask if do you have any other questions that you would like us to answer? I think now is the time. So please. Yeah, Alexandra is asking if we could send the link to this tutorial. I think that we can send the link, right? We can add it to the chat. Is it possible? Or maybe you are asking about today's session. If you want today's session, then you will find it on YouTube. You will get on your email a link where you will have the chance to access all the lessons, and you can view again everything that was discussed here. Did I manage to answer your question? I see that the link is in the chat, but it was sent only for us, Dmitry. Do you see it? It's the right link?
Let me check. It's in the chat. Doc Ultralytics. Right. Yeah, that's correct, Mikhailo.
Okay, so I will send it to everyone right now. Good. Let me share my screen. This one, yes. Okay, so these are my last slides. You will see it's about getting in touch with you and you with us. So please feel free to contact us if you have any questions and proposals by the email address that you can see on this slide. Stay tuned for our next initiatives. Submit your contact in the pre-registration form via the QR code that you're seeing on your screens, and you will receive announcements and invitations to our next initiatives. And for tomorrow, we will have our colleague Roman, so please join our tomorrow session. It will start at 6 p.m., 5 p.m., depending on which country are you in. But we will be here and waiting for you, and hopefully we will have a nice presentation as we had today. So thank you very much, Dmitry, for your presentation, for answering all the questions. And thank you all of you for being part of today's session, and see you all tomorrow.